In this lecture, we will talk about native prototypes in JavaScript. We have already discussed some of them, for example, object.prototype and array.prototype. But there are many other built-in prototypes, for example, function, date, regexp, map, promise, set, error, and there are native prototypes for some of the primitive variable types, for strings, numbers, and booleans. Okay, let's now examine prototype chains for some of the built-in prototypes. And let's first look at the prototype chain for arrays. If you create array, for example using array literal notation or using new array syntax, you create instance of the array.prototype. And every instance of the array will have numeric properties and one named property called length. And array.prototype contains a lot of array helper methods that are available for every instance of the array.prototype. For example, push or for each. Array.prototype has its own prototype, and it is object.prototype. And inside of the object.prototype, there are methods that are also available for every instance of the array because of inheritance. And prototype of the object.prototype is null. And we have already discussed this. Okay, if you create new array using such command, you create instance of the array.prototype. And if you access proto property of the variable a, it will be equal to array.prototype. If we will dig deeper and access prototype of this prototype, then we will get object.prototype. And prototype of object.prototype is null. And that is the structure of the prototype chain for all instances of the array. Remember that there is hidden property called prototype in two pairs of square brackets. And under the hood, JavaScript engine uses this property when it moves through the prototype chain from bottom to up. For example, if we try to call toString method on the variable a, we will check first on properties on the instance of the array. If this property is missing, it is missing here, we will check its prototype. In the array.prototype, this method is also missing. That's why we will go up again. And here in this object.prototype, this property will be found, and that's why we will be able to call this method on variable a. Okay, I will not show this in action because before I have already created instance of the array. Let's move on to next built-in prototype. And let's talk about string. Prototype chain looks here similar to prototype chain for arrays. But here there is string.prototype. And this prototype has such methods as toUpperCase or last index of. And when you create new string, for example using this syntax, you think that you create a variable of primitive variable type, but under the hood you create instance of the string.prototype. And that's why you have access to all methods of the strings. And if you will check prototype of variable a, it will be equal to string.prototype. And of course, prototype of string.prototype is again object.prototype. And same as before, prototype of object.prototype is null. Okay, let's now try this in action. I will create new string const a equal to empty string. And if I access a, I get simply string. But I can try to access its property to underscores, proto to underscores, and check whether it is equal to string.prototype. And yes, it is equal. And if I will move one level up through the prototype chain, like this, I will get object.prototype. And prototype of this prototype will be null. Okay, let me create one more variable, const b equal to hello world in lowercase letters. And here, because b is instance of the string.prototype, I can access methods of the string prototype. For example, I can perform toUpperCase action. Call this method, and here I'll get hello world in capital case letters. So what happens in this case? Here on this line, I assign value hello world to this variable b. And this is primitive variable type. It is string. And if I access simply b, I get string. But if I try to access one of the methods that are located in the string.prototype, like to uppercase, this value is converted under the hood to instance of the string. And that's why you are able to invoke such methods. If you want, you can create instance of the string prototype explicitly. For example, like this: const c equal to new string, and here pass string as an argument. For example, another string, like this. And now if I will access c, I will get an object. And here you see that this object contains numeric properties and one named property, same as in arrays. And you see that its prototype is string.prototype. And here you see a bunch of methods available for every string. Let's find two uppercase here, and here it is. And prototype of string.prototype is, of course, object. Here it is. Okay, that is explicitly created instance of the string. And its prototype, c proto, is equal to string.prototype, same as with variable b. So we can say in this case that c is explicit instance of the string and b is implicit instance of the string. Okay, let's move on to the next built-in method and let's talk about numbers. With numbers, behavior is the same as with strings. So number is primitive variable type. And if you assign value to the variable like this, const a equal 5, you create instance of the number under the hood. But visually it looks like primitive variable type. And this number will be instance of the number.prototype. This prototype has such methods as toFixed or toExponential. And those methods are available for every number in JavaScript. And parent prototype of number.prototype is as usually object.prototype. Okay, let's now try this. I will clear console here. And here I will create new variable const x equal to 10. So 10 is primitive variable type, it is number. And if I access x here, I will get simply 10. But if I will access proto property of this variable, I will get number.prototype. Here is true. Behavior here is similar to strings. Each number under the hood is instance of the number.prototype. And here I can call any method available in the number.prototype. For example, toFixed. So x toFixed, and here it expects number, for example 2, and I will get string. And this string is equal to 10.00. It means that this function converts any number to string with specific number of decimal places. If I will create another variable, for example, const y equal to 5.1234, and if I will invoke this toFixed method here and pass 3 as an argument, I will get this string. So this number with 3 decimal places. Okay, same as with strings, I can create instance of the number explicitly. For example, like this. Let me clear console and perform this action. Const z equal to new number and pass here number 10 as an argument. And now z is object. And this object is instance of the number.prototype. And here you see, for example, toFixed method. And of course, prototype of this prototype is object.prototype. And what is interesting, here down below, you see hidden property called primitive value. And this hidden property looks like this hidden property, prototype. But this property is invisible, but for number, you can see its primitive value here in the console. Of course, you are not able to access it here directly. You will get an error. Let me copy it, paste here, and here is error. Okay, as you see, you can create instances of numbers or strings. Same is with booleans, but this is not recommended. Usually you should create numbers, strings and booleans without using new keyword and create strings using string literal, so simply put string in single quotes or double quotes, create number as a number and boolean as true or false. But please keep in mind that under the hood you create instances of corresponding prototypes. Okay, let's move on, and next let's talk about functions. But let's go on with this after the small pause. See you.